Let's now turn to problem number 24 to state and prove the factor theorem for polynomials. The statement of the factor theorem is that suppose that f is a complex, a polynomial with complex coefficients with degree at least equal to 1, and let alpha be some complex number. Then f of alpha is equal to 0 if and only if x minus alpha is a factor of f. The proof of this relies very much on the remainder theorem. So if f of alpha is equal to 0, that happens if and only if we can write f of x as x minus alpha times q of x plus 0. That's from the remainder theorem, that if the remainder that you get when you divide f of x by x minus alpha, the remainder that you get is the same thing as what you get when you figure out what f of alpha is in the first place. Okay, so with that information, then that of course is exactly the same thing as stating that x minus alpha is a factor of f. And that's the end of the proof. So the factor theorem is a direct consequence of the remainder theorem. The last question that I was asked about was problem number 26. Explain when and why synthetic division works. Synthetic division works when you divide by either x plus c or x minus c. Why does it work? Well, let's do a quick example to see why this works. So let's just pick a couple numbers out of the hat. 2x squared plus 5x minus 1, and then divided by x plus 2. So let's do the division here. 2x, that's 2x squared plus 4x. So x minus 1. Then up here gives me plus 1, and then x plus 2. And so subtracting, we get minus 3. So the quotient of 2x plus 1 and the remainder of negative 3. With synthetic division, we'd have 2, 5, minus 1, and we're testing out negative 2. So 2 times negative 2 makes negative 4. 5 minus 4 is 1. 1 times negative 2 is negative 2. Negative 1 minus negative, or negative 1 plus negative 2 is minus 3. So again, 2x plus 1 with a remainder of negative 3. So in a nutshell, the reason this works is because I'm testing out 1x plus or minus something. Instead of having a plus sign, I flip the sign to be minus. And to compensate, instead here I subtracted, over here I'm adding to compensate. So I have a minus here, an extra minus here, and an extra minus here when I'm adding as opposed to subtracting. Those two minuses kind of cancel themselves out, and so that results in this much more compact way of writing down the division. And again, this only works because I'm dividing by 1x, so that when I divide by 1x, the number that appeared here, 2 in this case, goes straight here to 2. Likewise, 2, if I just bring it on down to 2, that also works. So when I subtract here, 5x minus 4x is 1, so the 1 here is going to be part of the quotient that's up here. So that's in words what's done. There's actually a kind of a much more formal proof about this in the textbook, but that's all I was looking for problem number 26.